Welcome to Math 2210. We'll do some work problems from Chapter 11. First problem, we'll deal with goodness of fit. So the problem reads, historically speaking, the percentage of majors at a science college was as follows: 20% physics, 30% computer science, 40% biology, and 10% chemistry. Now this year, 20 randomly selected students are questioned about their majors. The results are 2 physics majors, 9 computer science majors, 8 biology majors, and 1 chemistry major. So is the distribution different from the past? In other words, have things changed? The goodness of fit test that we'll be doing is called the chi-squared test. Chi is a Greek letter. It looks a little bit like an X, so it's read chi-squared. You always write it with a subscript which is equal to the degrees of freedom. I'll talk about how you get that in just a moment. Okay. In order to do this on the calculator, we will be entering some data as L1 and L2 like we've done before. Let's first write down what the values would be. Now, in the first column, L1, we're going to write down the actual results from our survey. So 2 for physics, 9 for computer science, 8 for biology, 1 for chemistry. And then in L2, what we're going to do is write down the expected results based on the historic long-term percentages. Now the way you do that is consider how many people are in the survey. There are 20. Historically speaking, 20% of the students were in physics. So to get the expected number of students in physics, we would take 20% of 20. So you do that on your calculator, 0.2 times 20, and what you'll get is 4. And then computer science, 30%, so 30% of 20 is 6. Then 40% of 20 is 8. And finally for chemistry, 10% of 20 is 2. Notice that the numbers I wrote in red add up to 20. If they didn't, it would mean we made some mistake. And by the way, you may get decimal numbers as you do this also, like 4.1. Okay, so again, L1 were our observed results from the survey, and L2 would be our predicted results based on those given percentages. Okay, before I pull up the calculator, just want to do one more thing. The null hypothesis, when you're doing a goodness of fit test, the null hypothesis is always that the distributions are the same. You could also write that as, in other words, the distributions are equal to each other. So no real change. And the alternative hypothesis would be that the distributions differ. I'm sure you'll recall in the past I've told you that the alternative hypothesis never has the equal sign. The null hypothesis does. Well, are the same, right? That's equal. Differ means not equal. So same pattern that we've always seen before. Let's see. There's one more thing I have to tell you. For this particular chi-squared test, here's how you get degrees of freedom, and the calculator will ask you for this number. So unlike some of the things we've done before, we didn't even have to worry about what the degrees of freedom were. We got it as our output. But here it has to be inputted. So what you do is you look at the number of categories. They'd be the number of rows in this table: physics, computer science, biology, chemistry. Those are 4 categories. The degrees of freedom is always the number of categories minus 1. So 4 categories minus 1, this will be a chi-squared with 3 degrees of freedom. Okay, jot down these figures and then catch up with me as we switch to the calculator. So first I have to enter those 2 lists. So remember, I go to Stat, number 1, edit, is where you put those in. I'm sure you all remember that. Okay, well let me go in here and clear this data. Probably had from the last video I did. So L1 is the 2, the 9, the 8, and the 1. 2, 9, 8, 1. There we go. And then remember, L2 was the like the expected values you'd get, where we multiplied 20 times our percentages, and that was 4 and 6 and 8 and 2. And let's just go and glance at these. Now obviously these numbers are not, these rows are not identical. They're similar to each other, but of course, you know, you'd expect that from year to year there'd be some variation. So what this test will tell us is, you know, was there enough variation to come to the conclusion that our distribution has changed? Okay, let's exit from this and let's go find the appropriate test. So you go to Stat, and of course you go to the test column, and this one will be very easy to find. Let's scroll down a ways. You're going to see that there are 2 chi-squared tests, but the second one listed under row D here, GOF, that stands for goodness of fit. So chi-squared goodness of fit test, that is the one that we will want to select. And look how easy it is to do. You just enter your 2 lists, your degrees of freedom. So that is, let's see, I have to change one thing. The degrees of freedom is not 5. Remember, there were 4 rows, 4 minus 1, so we get degrees of freedom is 3. And let's calculate. Okay, so do we reject the null hypothesis? Well, you know that you look at the p-value. If p is low, h null must go. P is not very low at all, is it? So in this case, we do not reject the null hypothesis. We don't have good reason to believe that the distribution has changed. Okay, well let's advance to the next problem. In this example, we're going to see how you can test for independence, whether things are dependent or independent. Now in the news, you'll often see polls giving people's attitudes about, all kinds of things, maybe gun control, abortion, charter schools, school choice, things like that. And sometimes you'll find that the result of the polling seems to differ quite a lot between whether or not you're asking men or women a particular question. So here, if we're independent of gender, then it's saying, it doesn't really matter if you're a man or a woman. Dependent might mean that women are more or less likely to to favor something. So here I've given some imaginary results of a national poll. We're going to see if the individual's opinion is independent of gender. So, the famous comedy team, the Three Stooges, we're asking men and women whether or not they like the Three Stooges. Now, I had to fudge this data so it wouldn't be obvious, because if I used real-world data, you'd probably find that almost all the men liked the Three Stooges and almost all the women did not. If you don't know who the Three Stooges are, you are culturally deprived, and I want you to fix that. Okay. We're going to do a few things to set up this problem, and before we go into the calculator and do our appropriate test, there will be a little bit of work. Preliminary work that you'll always want to do. First thing, let's just get some row and column totals. So notice that there are a total of 100 men in this survey, and there are a total of 40 women. For liking the Three Stooges, there are a total of 70. Don't like them, total of 70. Notice whether you add the rows or the columns, your grand total is 140. 140 people were obviously included in this poll. Now we're going to be setting up a pair of matrices which will contain numbers. The first matrix is easy. It's simply the observed matrix. What did the poll tell you? And you simply take those four numbers from the poll. So the observed matrix would be, first row is 53 and 47. Next one is 17 and 23. And then what we're going to do is calculate an expected matrix. I'm going to show you that for this particular matrix it's very easy to do, but then I'm going to come back to this a little bit later and show you how you handle tougher examples. Okay, now first off, notice of course that according to this data, like the Three Stooges are 70, don't like there are 70. You know, so we could say basically there's a 50% chance that someone likes the Three Stooges. Now, we're starting out with the assumption that these results are independent. In other words, it makes no difference whether you're male or female. So our null hypothesis will be basically that our distribution is independent of gender. And then the alternate hypothesis will be not independent. Think of the word not as being like a, not equal to sign, and you can see, just like every other test we've done, the alternative hypothesis never has, excuse me, the equal sign. Not independent would mean dependent. Okay, back to getting these values now for the expected matrix. Well, if it makes no difference whether you're a man or a woman, then half the men should like the Three Stooges and half of them should not like the Three Stooges. There are a total of 100 men, so that would be a 50 and a 50. Now for women, there were 40 women total. Half the people in the overall survey liked the Three Stooges, so half the women would be 20, would like them, and half of them would not like the Three Stooges. So this is our expected matrix. And we're ready to go start doing some work in the calculator. So let me pull up the calculator here. Let's see, I need to exit from where I was. And first we have to enter these two matrices. See over here on the calculator in blue you have a matrix button. So we'll do second to get there to our matrix. And the very first thing you do here is you go over to edit. Just like before, to input something we do edit. Okay, so we're editing, we'll be editing our first matrix here. So I'll enter there. Now, the first thing I have to do is put in the size of the matrix. It's a 2 by 2 matrix. 2 rows and then 2 columns. In these examples, it'll always be a square matrix, so it'll always be like 2 by 2 or 3 by 3 or 4 by 4. Okay, now let's go start entering the numbers. So let's see, I'm looking at what I did on the previous page. I have a 53. Underneath it I had a 17. Let's see, over here I'll have a 47. And then a 23. So let's just check that. Okay, numbers look good. Okay, so we'll go and we'll quit that. I have to go and enter another matrix cell. So I do the same thing for the second one. matrix 2, or B, I guess calling it matrix B. Again, size 2 by 2. Sorry there, it looks like I went over too far. There we are. And if you're doing this along with me, remember the numbers in the first row will be 50. Numbers in the second row will be 20s. I notice, at least on my calculator here, I had to go down before I could go over. Now, I don't know if that's true of yours. I don't know if that's just something funny going along with this one. But anyway, experiment to get into the various places here. Okay, and there we are, 50, 50, 20, and 20. So we'll get out of this thing here. So we entered our matrices. And now let's go to Stat. We're going to go and do a test. Oops. Why am I making silly errors here? There we are. Now let me scroll down. The tests in this chapter are going to be using chi-square, and you might remember from the last example there were a couple of chi-squareds. Now the previous example was a goodness of fit test. This is a test of independence. It's simply what you see there, C, the chi-squared test. Select that. Okay, you're supposed to enter matrix A and matrix B. We've already entered those, so we're in good shape. All we have to do is go down to calculate. So this is a real easy one as far as entry goes. And so let's see. We have here P equals 0.26165. That's not a very small p-value. We agreed to let alpha equal 0.10, but this p is bigger than any alpha people would reasonably choose. And so we would not reject the null hypothesis. We have no reason to reject these being independent of each other. Now, if I had put in numbers that were much more lopsided, like men clearly overwhelmingly like the Three Stooges and women overwhelmingly did not like the Three Stooges, then we would have gotten a very small p-value because our conclusion would have been that the results were dependent on gender. I'm going to go back to the PowerPoint to finish up this video because I just want to show you how you get these expected values when you're doing, say some of the harder homework problems. And there's actually a very simple formula that you can use. Let me go and it won't erase because I'm not in the slideshow mode. There we go. Okay, now I can go and erase these things. Okay, here's how you can get the expected values. I'll use blue ink to show you this. Expected values, you could consider other numbers in these cells. So observed are the numbers that were given, 53, 47. Expected will be these ones I'm going to calculate for you. To get any expected value, like this one right here, you can use the following formula. You can take your row total times your column total and divide it by the grand total. So let's look at that figure there in the cell where we see 53. The row total would be the 100 here, the row corresponding to this. So that would equal 100. And then it would be times the column total. Well, to get the column total, you look down here. That column total is this 70 right here. And then you divide by the grand total of 140. And if you do that calculation there, you will find that it equals the 50. And you check it out and try it for these other numbers. So when you're doing a homework problem, you know, there may be numbers that are much more lopsided and so on, unlike this where I had 50% liking and 50% not liking. And just try this formula. Should work out fine. Just make sure that when you're all done doing your expected matrix that you get the same, you know, grand total and the same number of men and women in that. You know, in other words, just make sure all your total values work out okay. If not, you've made a calculation error. And that ends this video.